Afternoon, everyone. Welcome to the latest of our Telecoms Sector Group webinars. For those of you who don't know me, I'm Paul Graham and I head up Fieldfisher's Telecom Sector Group. As a group, we cover all of the key legal and regulatory issues for our telecom sector clients. I'm really delighted today to be joined by an extremely distinguished panel of experts to discuss some of the key developments in cloud transformation and open computing as they affect the sector. So joining us today, we've got Joanna Newman, who's the Principal Cloud Transformation Lead for Vodafone Group, Steve Helvie, VP for Channel Development at the Open Compute Project, Eugina Jordan, VP of Marketing for Parallel Wireless, William Webb, CEO of Weightless SIG, and last but not least, Stephen Douglas, who's Head of 5G for Spirent. So just a few housekeeping points before we move into the panel session. All delegates, as you've heard, will be in listen-only mode, and all being well, towards the end of the session, we'll have an opportunity for Q&A from delegates. So if you have questions that you'd like the panelists to comment on, please submit these via the question function in the sidebar. So by way of introduction, companies of all sizes and in all sectors during the pandemic have taken it as an opportunity to accelerate their digital transformation projects. And this is really changing the way that businesses operate and create value, and changing the way that products and services are delivered. Advanced technologies will also introduce an opportunity to transform the designs of new and existing services in sectors as diverse as healthcare, smart cities, mobile services, IoT, manufacturing, and AI-based services. And this digitization process will challenge the status quo and affect how policymakers, regulators, and private sector companies consider how best to fund the investment in infrastructure required to support these services. And the result ought to be a new wave of innovation in the UK and beyond. And the hope is that open computing and telecoms infrastructure and cloud first policies will be the foundation of this innovation. Telcos and the ICT industry more widely having to evolve to deliver infrastructure which leverages emerging and maturing concepts such as open platforms, open computing, and open hardware. On the 5G side, the 5G services and use cases which demand lower latency and device densification will require the emergence of mobile edge computing, which enables data to be processed nearer to the point where it's being generated and collected, in order to enable organizations to analyze data in close to real time in order to enhance the customer experience. So to kick off the discussion, I thought it would be good to consider the role of hyperscalers and open computing in the sector. So during the last year, major telcos such as Vodafone, AT&T, and Telefonica have put together deals with the likes of AWS Wavelength, Microsoft, and Google to enable edge computing to that operator's business customers. So the first question I thought we'd explore today is, what are the technical characteristics of the services and which use cases are gaining most traction with business customers? So in order to start it off, Joanna, would you like to start off on that particular question?
Sure, thanks, Paul. So at Vodafone, I led the launch of Europe's first multi-access edge computing MEC platform. We partnered with Wavelength to deliver that back in London in June. And so from the edge use cases that I'm seeing, the short answer is that they're everywhere. So they're what you've already covered in your introduction. So IoT, AI, smart cities, manufacturing, industry 4.0, etc. And actually the growth of this industry is expected at more than 150% per year. And that's one of the lower numbers that I've seen from the various research institutions. So this is a huge growth area for everyone. And what's really nice is the amounts of pilots and proof of concepts and exploration that's happening to find out what's happening and to build some use cases and to try things out. typically these use cases have a few characteristics in common. So edge computing is about bringing the computing closer to where the interaction actually sits. So abstract it out of the center of the core of the cloud and move it closer to the edge. That's why it's called that. So by bringing that computing closer to the edge, you enable a whole host of use cases. Some of those use cases have been there already and are just being improved, and some of them are brand new. And they all take advantage of the low latency that you get because you've got that computing so much closer. It's so much more responsive. And you see things like that in self-driving cars and V2X in that space, but also AR, VR, and drones as well. And then if you think about the fact that you've got your computing closer to you, you actually have more control over what happens with your data. And data sovereignty is a very hot topic, especially in Europe, and in some parts of Europe, it's very strict indeed. So it allows you to hold on to your data and to secure it more than if it was being dumped into a central cloud and moved around the world, et cetera, et cetera. So that's another characteristic of some use cases there. Multi-access edge computing has come from the standards organization. So this is something that all operators will have the capacity to do as they migrate into a 5G world, and wherever they are on that continuum is where it's going to happen. And multi-access edge computing is available for 4G as well to start, and it will only get better and better in time. So if you think about that computing coming along, that enables things like in Industry 4.0, robotic precision manufacturing, as you've got coverage across the entire factory floor and you can run robotics with confidence. You can see things like location-based AR and VR, and there'll be some really interesting use cases coming from that that will apply to the sports world, but also apply to more critical industries as well, or critical use cases, mission critical use cases. And we're really just at the beginning of enabling, of seeing network slicing available across operators. So this isn't a Vodafone answer, this is an industry answer. Network slicing, quality of service, etc. You put that together with the millions of connections you get from IoT for 5G, and it's really a brave new world. It's really exciting, and I think that the answer that I've given here today will be completely different in 6 months' time as more use cases come along of drones looking at ports, or inspecting construction materials, or inspecting vehicle manufacturing, etc. It's really happening everywhere. Thanks.
Great. And so you've covered there some of the benefits that AWS Wavelength and Microsoft has over traditional on-site computing. What about the way that carriers are actually delivering those benefits to clients? Anything more to add on that?
Sure. So multi-access edge computing, or MEC for short, is really a combination of that compute that's closer and usually provided from a hyperscaler, so it's cloudified computing, together with routing on the network that makes it much faster to deliver much more responsive, supporting those millions of connections. And one of the nice things about this is that some of the installations, they can be for a factory, and that's called a campus-based installation or a metro-based installation, or they can be a geographic footprint. So it could mean that all devices from that operator under that in that geographic footprint, which can be quite sizable. The London footprint is London and the surrounding area, all have access to take advantage of this capability. So it's really exciting to see that even without doing anything on devices, you might be able to reap the benefits already. And I think that's what you get with using multi-access edge computing, which is a combination of hyperscaler capability and the mobile operator networks. And again, this could be anybody that's doing it. It just happened to be us first. Now, the other thing I want to call out is that on-site computing, there are use cases that require it, but they are few and far between. So this also takes advantage of the fact that people are cloudifying their estate and taking advantage of cost benefits and intensive capex heavy investments, and offloading that into an OpEx model by cloudifying and moving to cloud native principles. In Vodafone technology, we have something called golden rules, and one of our golden rules is cloud first. Cloud native first. It needs to be considered under all circumstances. So that's the benefits. You've got cloud capabilities as well as mobile capabilities. Thanks.
Perfect. Great, thanks, Joanna. And Steve Helvie, I wondered if you wanted to add to that. We've had the operator perspective, but just the perspective of OCP, and if you want to explain a little bit about what the Open Compute project is about.
Yeah, sure, Paul. So the Open Compute project, for those of you that may not be familiar with it, it's an open source hardware project started by Facebook in 2011. And at that time, they were outgrowing their infrastructure. So they were buying traditional servers, but it just wasn't fitting their need. They needed a purpose-built server. So they worked with the manufacturer to design their own servers. They also designed their own data centers at that particular time. Around 2011 is the first time they built their own data center. And they took it a step further. So large companies working directly with the manufacturer to make a specific product is not new. What is new is afterwards, they decided to open source it, and using a community-based engineering principle, they open sourced that. And now we have over 250 companies, primarily most of the large hyperscalers, with the exception of one or two are participating, as well as a variety of other types of companies, working on, say, 25 to 30 different areas within the data center. So we have around 8,000 hardware engineers working in an open source hardware community. And that's new. It's different because open source has been around for quite some time in software, but now it's making its way into the hardware arena. So that's a bit about Open Compute. A couple of things that Joanna mentioned were pretty interesting. One is I agree that if you look just 6 months from now, it'll be completely different than what we're talking about now. And she did say that there were specific use cases for on-premise type of deployments and then the cloud native software. So if I look at the two areas, when I speak with enterprise companies looking at software versus hardware, they are creating cloud-enabled software packages, but those software packages may be running on their on-prem. So it's really about the architecture of the software itself. Not necessarily, it doesn't need to necessarily reside in Azure or AWS or Google. It can reside on their own infrastructure. The other piece that has changed quite a bit for us is the definition of a data center. So as this moves on the telco space, you had the core data center moving out to the edge, and now it's moving into all these other different use cases, which Joanna mentioned. So there are a couple interesting things that happen from the hardware standpoint, is you have within these open source communities, you can create different types of form factors. So instead of a traditional pizza box type of server, you now have shorter form factor servers and different GPUs or accelerators that can fit in these different types of form factors, whether it be on the top of a roof or in a barge sitting next to the bay. That is changing dramatically. The rack size, the power configurations. As Joanna mentioned, the AI components, this creates a lot of heat within the data center. So if you have a modular type of data center sitting on top of a roof, you're still creating a lot of heat based on those type of AI workloads that you're using. So one of the bigger initiatives that we see within Open Compute is how do I reuse that heat? There are countries now in Europe where you cannot build a brand new data center unless you have a heat reuse plan in place, Amsterdam being one of them, and Singapore quickly to follow. So as we look at these different things, Joanna is spot on when she mentions all those different use cases. What we're seeing is a different definition of what is a data center now, how do I reuse the heat, and what new form factors can I use to accelerate those on-premise workloads that are not necessarily needing to run on the cloud.
Okay, now Steve, just to go on, what do you see as the benefits for the software development community in terms of the benefits of Open Compute and the platforms being rolled out by the major telcos and hyperscalers?
As most people say, well, what's the benefit of this particular solution over the other? It's typically CapEx and OpEx. Those are the two buzzwords that people say. Now, do I realize the CapEx and OpEx, and is 10% what I'm shooting for, is 25%? But what we're seeing is on the software side, when you disaggregate and you remove the software from the hardware, you commoditize that hardware. So one of the tenets of Open Compute is I need extremely simple, efficient hardware. I do not need brand names. I do not need all of the extras that come with big brands of boxes. So I can commoditize that. Everything runs on software. And then that way I can get rid of all the things that I don't need in the hardware. So what the other big component within the software piece is it being open source. We are seeing a proliferation of open source software pulls through open source hardware. There is a typical profile. If somebody's looking at open source hardware, I can ask one question, and that is, how much open source software do you use in your organization? If I sit with a traditional bank in APAC and they say, well, we're kind of looking at this software for open source, I know that they're not a big open source user and they're not going to understand this model. It's a very fluid environment. When you start to work with open source communities, it's not pick up the phone, call one vendor and have a team of 50 people on site 24/7. It is, you're working with different vendors, you have to wait for updates, you have to commit to the community. So it's a different procurement model, it's a different mindset. So those companies that are more open source minded, whether it be working in the cloud or on your own premise, are the ones that are seeing the most benefit on CapEx. CapEx numbers that we've seen lately for open source hardware has been between, say, 30 to 50% when you get rid of that big brand. On the OpEx, it's between, say, 20 to 40% on the OpEx side, depending on the type of hardware that you're using.
Great. I mean, those are really compelling numbers. And in terms of just moving the discussion on, in terms of the topics of cloud native architecture and OpenRAN, I mean, last year the world's first fully virtualized cloud native architecture for mobile networks was implemented. I guess I wanted to pose the question to the panelists. What do you see as the consequences for mobile network operators of the strategies of companies like Parallel Wireless, Rakuten, Mavenir, and Reliance? And maybe William, if you want to answer that one.
Yeah, sure. So on the one hand, you could say if you're an operator, well, this is all just good. It's another supplier into my marketplace. So in the past, I could only buy RAN equipment from Ericsson and Nokia, the major vendors. Now I can buy from Mavenir and Parallel Wireless too, so I've got a bigger supply base. That's all helpful, that's all good stuff. I might expect that there'd be more competition in the supply base, and that might reduce my pricing a bit, and diversity is all a good thing. So that's the easy view. I think the interesting point is to look at the operators that have emerged who've based their strategy entirely on OpenRAN and similar constructs, and Rakuten are obviously the poster child for that. And to ask whether those kind of operators are gaining a competitive advantage over conventional operators because of the potential benefits of OpenRAN. And Rakuten tell a pretty aggressive story that their cost base is substantially lower than the major operators as a result of using OpenRAN. I think there's some doubt about that, but that's the story they tell. Actually, at the moment, if I were a major operator and looking at Rakuten's current performance, I would not be in the least bit concerned. They've not done very well at all to date. Now, maybe that will change, but they certainly are not eating the lunch of the major operators in Japan at this point in time. And there's no evidence that they're likely to in the near future. In fact, more likely is that they'll have funding issues over the cost of rolling out their networks going forward. So actually, there may not be a kind of an immediate kind of competitive concern from the operators. I think it's just then a case of to what extent do they want to aggressively help the OpenRAN providers in order to foster that kind of supply chain into the marketplace, or do they want to sit back and wait and see what transpires out of all of that?
Okay, and Stephen Douglas from Spirent, what are you seeing in the sort of vendor community? Because you're pretty close to that vendor community.
Yeah, I mean, just to follow on from what William said, I mean, I'd agree what he's saying at the moment. But I would temper the fact is that I think we get maybe caught up in the hype around OpenRAN that it must succeed immediately today and it must always be adopted. I think the strategy, what we're seeing from the community, and especially a number of the service providers who are supporting it, is that they're not vesting that interest that it has to succeed in the first few years here. They're seeing it as a longer term strategy, leading beyond even 5G and towards the 6G system. And I think that's part of the strategy. This is the bedding in period for OpenRAN in reality. It's going to take a number of years, for its adoption. It's easy for a C-level, to say we support OpenRAN, but getting the broader, if a Vodafone's organization, down to the ops teams, the maintenance teams, all gradually supporting it, takes time. And that's what we expect to see. I think the strategies, though, are radically different, Paul, in terms of, if you look at what, say, Parallel and Mavenir are doing compared to Rakuten, there's quite a difference in that. Rakuten's coming to the market very much more with I would really say it's a pre-integrated OpenRAN solution, which you could argue how open really is that. Well, at least I think what Parallel and Mavenir are sort of positioning to the market is a more, I would say, the more pure view of OpenRAN, where it's pure interoperability. You could plug and play components into it, and I think is either approach the right approach? It's unclear at the moment, because there is still a headache that the industry is trying to solve at the moment, that somebody has got to integrate this together. And you're going to get some customers will want to buy a pre-integrated solution, and Rakuten may be the right approach to go to, to get that. While others will prefer, the models that sort of Mavenir and Parallel are certainly, coming to the market with. I think the other thing is just, that what we're seeing at the moment is just, I suppose, really the use cases around it. How it's in this early stage, is it being seen and adopted, and we're starting to see some of the early roadmaps appearing from the service providers in terms of where they're potentially going to start with OpenRAN. It's not necessarily going to be the big replacement of, suddenly it's going to, take over everything that an Ericsson or Nokia is going to do. They're going to start small. In some cases it may be rural, in some cases it may be, even indoor small cell. Gradually, you're going to see that evolve out over the next years, though, into the non-dense urban and then into the dense urban deployment. So I think you're starting to see that maturity of vision starting to appear.
Got it. And Eugina, did you want to sort of comment there? Because obviously you've got a great view. You're on the inside at Parallel Wireless, and you have a sort of global view of the company. What's Parallel's view of the sort of coexistence with the existing operator community?
Thank you so much. For some of you that don't know Parallel Wireless, we are an OpenRAN software company, and we provide software for the RAN across all Gs, 2G, 3G, 4G, 5G, and hopefully 6G in the future. So our view on OpenRAN, it is an operator-driven strategy. Vodafone, Telefonica, and many other operators, they've been driving OpenRAN for many, many years. It didn't just start yesterday or last year. We've been working with Vodafone for over 4 or 5 years because they saw the need to drive the cost down in the network. Supply is consolidated. Let's be realistic. In some regions, like in the United States, we only have 2 suppliers. So if you go to a supermarket and you have only 2 cereals, what are your choices, right? So you want to have a long line of cereals, and you want to add different toppings. And this is what OpenRAN is all about. It's mixing and matching components. It drives innovation. It's not about displacing Huawei or Nokia or Ericsson. It's about bringing innovation to the ecosystem. Innovation has not been happening in the RAN for years, and OpenRAN is nothing new. We went through this movie first in consumer computing space, right, with Microsoft, when they put a big bet on software, and they won. Now, in 2000s, same bet was put by enterprise companies on software, and they disaggregated hardware and software, and then they automated. So it's nothing new. It's a natural progression. It's a natural evolution. And Parallel Wireless and other OpenRAN companies, software, hardware, or server, they're at the right place at the right time because operators are ready. They need to reduce the cost. The question remains why 5G is not picking up as fast as 4G, for example, did. Because it's too expensive to deploy. So, and that's why operators started looking at OpenRAN. And OpenRAN, it's not just about hardware and software disaggregation. Stephen Douglas was saying integration is necessary. Of course it is. So once you disaggregate all the components, then you are stuck with the pile of those components. And this is where the second stage of OpenRAN comes in, and Vodafone is actually leading that charge. How I'm gonna integrate it, how I'm gonna deliver the software. And DevOps, cloudification comes in. How I'm gonna deliver the software to my sites. With DevOps, continuous integration, continuous development. How I'm gonna automate my network optimization strategies with artificial intelligence and machine learning. So OpenRAN, it's not just about disaggregation. It's about automating the network for the end users to support all those new use cases that Joanna was talking about.
Okay, so you've really got a couple of emerging themes coming together in terms of microservices, containerization, and players like Docker and Kubernetes actually potentially having a place in the network space. I just wanted to pick up on the cost element there, Eugina. I mean, there are claims that sort of 60 to 70% of capex spend for operators is on the RAN. What do you see as being the realistic economic and technical benefits that operators can realize from deploying OpenRAN technology?
So when we look at the number 70%, it comes from the equipment. It also comes from the structure, batteries, all kinds of pieces of equipment, servers. So it's not just your radio and the software. So it's the overall total site cost. So in looking at, like Steve was saying, at just the component based, yes, you can see the 30 to 40% reduction by using commoditized hardware. But also you need to look at how you can reduce the labor cost, because it costs a lot of money to send people on site. In the US, the tower climb, just one tower climb, between $3,000 and $5,000. So, and if you have 1,000 sites, 5,000 new sites, multiply that cost. So this is where the automation comes in again, how you automate configuration of your sites. If you use ZTP, zero touch provisioning, you might not need to send those people on site. So, and this is how the cost with software can be reduced as well, by automating all those manual tasks. But we all know, and Joanna can attest, that operational costs, they're far larger than your CapEx expenditures. So the strategies with artificial intelligence and machine learning, how to optimize the network for optimal end user experience, they will reduce your OpEx. Because the hardware is already there, the radio software defined. You can turn it to be 4G, 5G, 6G radio. But how do you optimize your site to deliver all those new use cases? And this is where automation comes in. And this is how you can reduce the cost with those software techniques.
Got it, thanks. And just going back to Steve Helvie, just a little discussion on the benefits and constraints on the introduction of this hardware disaggregation strategy, with proprietary hardware being replaced by software-based network elements.
One of the things I love about these panels is I get a chance to learn from all these people. So that's some great tidbits there, Eugina, on the amount of cost it takes to climb a tower. I think on the benefits, or the benefits of this commoditized hardware and the software, you see large OEMs like a Nokia as an example. Just look at the open source organizations that they're involved in around RAN, whether it be the ORAN Alliance or TIP, the Telco Infrastructure Project, which was started by Facebook as well, OCP, etc. You'll see one of the ways that they're trying to protect is they're getting more involved in this. So one, on the areas of interoperability, which Stephen mentioned, somebody's going to need to put all this together. I anticipate there being a real market opportunity for these large SIs to start building practices around this, where in the past they maybe just had a proprietary OEM style of business. So I think on the benefits of the hardware itself, I do go back to the efficiency. One of the big benefits of this commoditized hardware is you can run it hotter, and it runs between 30 to 50% more efficient. And there are efficiency requirements now in Europe on how efficient a server must run at idle, because most servers are not being used and fully utilized. And there's also circular economy or embodied energy requirements around a commodity piece of hardware is going to weigh less. It does not have as many components because you've stripped out everything that you do not need in an OEM brand. These are the type of benefits that aren't necessarily prevalent. I'm not going to buy a commodity piece of hardware because it weighs 6 pounds less or 4 kg less. But ultimately, when I need to start measuring my scope 3 emissions and my embodied energy, and I need to report that up, those things are going to start to come into play. So those are just a couple of the benefits. I always go back to efficiency and the long-term sustainability that we see aside from the CapEx and the OpEx. On the software side, on the software side, I see a bit of a skill gap when I speak with customers trying to move this direction. They don't necessarily have the skill set or the resources. I did speak with one company and they said, look, I've got 5 engineers, software engineers. Where do I put them? Do I have them learn something new that I put on proprietary gear? Do I stick them on learning AWS? So what do I do with this limited number of resources? Because next year, I'm probably only going to have 4 or 3 engineers. So I do see a potential gap, and then I'd welcome Joanna's take on how they're seeing their software skill set develop.
Joanna, do you want to pitch in there?
Yeah, so one of the things that we're focusing on is really building our software development capabilities in-house, and we've been working on that for 3 or 4 years now. And we're looking at the skills that are really required to be able to operate one of the biggest telco networks in the world across 26 countries and 40 partner geographies, etc. So yes, we really are focusing on making sure that we've got the software skills and other skills to be able to operate that. Thanks.
Great, and then just circa, thanks, Steve. Really useful in terms of the energy efficiency, particularly with COP26 coming to Glasgow in November. Really topical. I can see a potential another webinar topic there. But moving back to the cost issues, William, what were your thoughts in terms of realistic economic and technical benefits from OpenRAN?
Yeah, and I think the jury's still out. And one thing, of course, to remember is it's really difficult to know what prices are. So, if you manage to get list prices, well done, but list prices are rarely what anyone actually pays. Operators typically pay 40% less than list prices or something like that. So comparing even list prices in itself is difficult. But I think Eugina made a good point. If we look at this holistically at the total spend of an operator, then it's whatever, roughly half CapEx, half OpEx. Of the CapEx, yeah, 70 or 80% may be on the RAN, but a lot of that is on the masts, the backhaul, the energy costs to the base station, all those other kind of things. The actual component of the RAN, the actual bit you go buy from Ericsson or Parallel Wireless or whatever, may only be 10% or less of total operator spending. And so if you manage to save half by buying it for half the price, then you might save 5% of your total spend, which is good. Absolutely, every operator would be pleased to do that. But we're not talking about some kind of revolutionary 50% reduction in total spending. And my guess is actually what will happen, of course, is that will exert competitive pressure on the existing suppliers, who will then reduce their prices too. And that's good. I think that's a great outcome from all of this, that essentially it exerts a lot more pressure on the overall supply chain to be competitive, to be innovative, to do new stuff than would otherwise be the case. So I think that should be a great result. In terms of technical benefit, initially ORAN is kind of a like-for-like replacement for other RAN, so there's no immediate technical benefit. Indeed, arguably the first versions of the ORAN stuff will be less competent than a fully fledged Ericsson base station that can do 2G to 5G and everything else, understandably. Over time, that will improve, of course. I think there's some interesting possibilities. The openness of some of the interfaces into the ORAN system does allow for third parties to provide all sorts of software, such as sort of self-optimizing network solutions and things like that. Again, that could lead to a lot more innovation than might otherwise occur. So we might see in the longer term a bit more innovation, a bit more technical advance around the OpenRAN side of things. But I think to Stephen's point, that's probably looking more towards the 6G era now than the 5G era, given that a lot of the bulk of the heavy lifting is done on 5G deployments. Got
it. And we've had a question in about the sort of progress of OpenRAN, but we'll save that to the end. Sorry, was that Stephen? Did you want to pitch in there?
Yeah, it was really just on both William and I mean, back to Eugina's point, which is I think sometimes gets overlooked a little bit, but and William highlighted there. I mean, one of the benefits we're hearing from a lot of the service providers we're talking about is that potential for flexibility of the RAN that OpenRAN could bring. And what they're talking about there is that I think there's a realization with the 5G network, the type of densification that is going to be required and the types of environments that the RAN has to be deployed in and use cases it's going to serve is radically different than anything they've ever had to deal with before with the 4G systems. And while the traditional RAN vendors certainly could offer certain solutions where the traditional sort of macro deployments maybe aren't best suited for that. And this is where OpenRAN could really have huge potential because of that dynamic sort of optimization, that flexibility within it to suddenly serve all of those types of use cases, which are going to be absolutely critical, as an operator wants to service different industries, different commercial sectors. This is where OpenRAN could really play a major role. And I think, it's not there yet, but I think that's the innovation side of it where OpenRAN, I think is, I think what a lot of operators would like to see, because I think that's really going to help them out in that sort of not only densification, but really cost efficiently getting into these new industry and vertical markets as well.
Got it. And I think you're sort of fairly neutral in your view on this, so I thought I'd ask this question to you. But do you have a steer on what extent existing that the major equipment vendors such as Ericsson and Nokia are likely to secure a significant percentage of OpenRAN investment?
It's a good question. I think obviously Nokia is probably more embracing of it than Ericsson is today. I think because there's another side to OpenRAN that it's part of it is the cloud, is Open Virtual RAN, and it's that virtual component part of it is where Ericsson's probably focusing on less than the open part of it. And I think they will take pretty big market share there. I think Nokia and Ericsson will still dominate probably a lot of this early 5G spend side of it. I think OpenRAN is slightly late, which is understandably so, to the 5G space. But that's traditional RAN, single vendor traditional RAN, which will pick up. I think as you start to see more of the pure OpenRAN coming into the market, then I think it will be slightly harder for Ericsson or Nokia to sort of take market share there. I think there will be very strong competition. What I'd expect though to see is you will gradually potentially see Ericsson and Nokia, I think, more embrace it. Simply because if you look at where the standards are starting to evolve towards, and again, I'll talk 10 years in the future out towards the 6G system, it is clear the industry is coalescing that an open architecture of the radio is where the industry wants to get to. And I think that is going to drive them in that direction.
Yeah, okay. I mean, we may come to that because we've got a question on regulation and the 3GPP release 17 and onwards. But Eugina, from the parallel wireless perspective, what advantages do sort of what I call pure OpenRAN vendors offer over other more traditional vendors such as Ericsson and Nokia?
Oh, I can't wait to answer that question.
Thought you might.
But I'm going to answer this question with a question. What are the incentives for Ericsson, Nokia, and other legacy vendors to support OpenRAN? Let's be realistic. OpenRAN is not a new technology. It's not a new standard. It's still 3GPP compliant. It's ORAN Alliance compliant. It's just a new way of building networks. Its ability to mix and match. So this week, I am in Phoenix at Competitive Carriers Association conference. And yesterday we had a panel. Parallel Wireless was on the panel, Rakuten, Nokia, and there was another company. And Nokia was telling those rural providers, because they're thinking about rip and replace, the grants are being given, the list is being finalized. So Nokia is telling those rural operators that their servers, the BBU servers, are much better than Dell and HP. They're more cost effective, they're more power efficient. Don't buy from Dell and HP, buy from Nokia. So what is the incentive of that representative telling that message to those operators? Or I have another story that I told during OpenRAN RCR Wireless Forum, is Ericsson has had software that could automate networks, and the leadership team shut it down. Do we want to live in that world where competition doesn't exist, where vendors say don't automate, don't buy from this vendor? Because OpenRAN is about innovation. It's about interoperability. So our incentive as a pure software OpenRAN provider is to drive that innovation. We build the largest ecosystem of OpenRAN radio providers, server providers, software providers. We build our software to go on any quad server. And if mobile operator decides to swap us out, if we don't perform well, hopefully it doesn't happen, they could swap us out with MyVeneer software, because this is what the true OpenRAN is about.
Got it. I knew there would be a passionate defense there. That was great, Eugina. I mean, I had one question. I remember watching one of the parliamentary select committees, and the various operators were talking back in July last year about the then imminent decision about swapping Huawei out of the UK's networks by 2027. And one of the things, one of the main operators in the UK was talking about was the single RAN concept. So having a coherent stack of 2G, 3G, 4G, 5G provided by one vendor, and avoiding the sort of overlay network effect. To what extent do we think that the single RAN concept might curb the introduction of Open RAN deployments? And Stephen, Douglas, do you want to sort of give some thoughts to that?
It's certainly a requirement from quite a number of the service providers, and some of the markets are going to need. They're certainly going to need that capability as they deploy, and certainly that's a push. It's set of, I mean, there's a number of requirements that have been put out by the operator community for that support, and I think you're seeing them work very closely with the new players in the space to try to address that. But you've also got to couple that with some of the turn-off planning that's happening also across Europe, whereas, you know, obviously it's the end of lifing of some of the G technologies as well, with some of the carriers as well. So it's got to align to that there as well, what they actually need as part of their underlay going forward. And that sort of activity that's, you know, we're certainly seeing it at the moment. And I think there's sometimes another overlooked one which doesn't get sort of talked about as much, which is also again the operator community's requirements for, you know, supporting off a lot of the emergency service capabilities that are critical for the radio side of it. And, you know, again, that's an area where they've identified, you know, the OpenRAN community needs to have more parity in that space, and that's certainly work that's happening at the moment. So, you know, as I said at the very, very start, when I said, you know, OpenRAN isn't, I know Eugina says, you know, it's been there for 5 years, and that's right, and I think they've done an amazing job of where they've got to, but, you know, we shouldn't expect them overnight just to have complete parity with systems that have been, you know, building for 20 years. I think what they're getting towards is pretty impressive already, but there is a, you know, a way to go. But what's very, very positive is that the operator community, and especially the operator community here in Europe, led by sort of Vodafone and Telefonica, is helping direct them. This is what, you know, we really need, you know, and giving them the guidance and encouragement to sort of to get there. And I think that's a pretty positive step.
Got it. And Eugina, did you want to chip in terms of how Parallel sees that single RAN concept? And because I know you were talking about Parallel having an offering into supporting 2G, 3G, 4G, etc.
Thank you. So I think there's a little bit of confusion going on when we say single RAN, because some people look at single RAN as one vendor RAN. So we need to clear that confusion in the market, because Delora just released a report and people jumped on them saying, oh, single RAN needs to be OpenRAN. So, we need to figure that out. So to Stephen's point on single RAN supporting 2G, 3G, 4G, eventually 5G, 6G, and whatnot, is OpenRAN is initiative that is not building the 2G or 3G from 20, 30 years ago. It's cloud native based 2G. It's cloud native based 3G, 4G, and 5G. And KPIs, that is why it is super important that operator community is involved, because KPIs that were important on 2G from 30 years ago are not important today. And you're absolutely right, Stephen. Vodafone is driving what KPIs are important to them and to their end users. And it is important for OpenRAN to understand what KPIs need to be delivered. Thank you.
Great. So our last question is around open interfaces and regulations. So the UK government has launched various initiatives such as Sonic and the UK 5G supply chain diversification strategy. And many of the 3GPP interfaces are open and standardized, but there are still some interfaces that continue to rely on the CPRI protocol and vendor-specific implementations. So the question is, what regulatory initiatives would facilitate the speeding up of OpenRAN deployments? So, for example, standards bodies and requiring open interfaces and the supply chain diversification. And that question to Joanna.
No, sorry, not for me. Thank you.
You guys going to pick that one up, actually?
Yeah, okay. William, if you pick
that. So yeah, I think there's a lot that can be done. You touched on standards bodies. I mean, we've had obviously a pretty significant flare up in the OpenRAN standards world in the last month with the ORAN alliances issues, with Nokia and Ericsson sort of temporarily withdrawing. Nokia's back in again, with the European Commission saying that the body is not a true standards body because it's not open. And you know, I've run standards bodies. I know that space well. And there are issues there that are fundamental and I don't think are going to go away anytime soon. So, you know, I think government potentially could help a lot there by sorting that one out before it becomes an annoying thorn in the side of OpenRAN and a potential derailing, frankly, if it's not clearly sorted out sometime in the next 12 months or so. We've also talked about 2G, 3G. I think, you know, governments can help there. They can help operators switch off 2G, 3G by essentially easing some of the requirements to support lots of legacy kit. In the UK, for example, we've got a ton of smart meters that are 2G, 3G connected, and you know, operators will breach contracts if they shut off 2G, 3G anytime soon. Or we could potentially effectively create a kind of single 2G, 3G network that at least allows most operators to move forward. So I think there's regulatory things that could be done on that side. The UK government has made life harder by putting security requirements on RAN networks, but it's also tried to improve that by Sonic and other test beds that effectively allow a single test point. So, you know, if governments are going to make life more difficult, they can help to remove some of that difficulty at the same time. Now, I think as well that there's, you know, it's probably more an issue of what can governments do to help the market at this point in time to really pull through equipment and grow that market faster. And, you know, there's all sorts of things they could do. There's various carrots they could have. They could, for example, offer mobile operators tax credits if they buy open equipment as opposed to non-open equipment. If governments are really keen to have more openness in the networks, then that's, you know, exactly the sort of carrots they should be offering the operators to do that. And they could make it easier to deploy private equipment, as Stephen has said there's quite a high likelihood of, if local deployments, small cell deployments, vertical deployments are more likely to be ORAN than not. And making sure that there's spectrum available for that, making sure that there's good knowledge and insight as to how to do that, making sure that there's all the sort of system integrated bodies and others that are needed to do that is something that government could help support. So I think there's a lot of stuff that could be done. And the UK is doing some of that, and other governments are doing other parts of it. But nobody, I think, has really looked at it holistically and said, if this is really a core part of our governmental national strategy, how do we ensure that it really is going to be a great success?
Got it. Did any of the other panelists want to chime in there on that particular issue about interfaces and regulation?
Just to reiterate William's comment on having the governments mandate open technologies. When we see governments around the world writing into their RFPs that they want open hardware, that pulls through a lot of the ecosystem, and it gets to a lot of it helps on the influx of new technologies. So when customers demand it, we have partners that fulfill that need.
Okay, got it. Yeah, and I guess that's right. With government being such a massive spender in technology, I think they could do a lot to help there. Well, we're running sort of fairly close to time, but we've got time for one question, and that is, when do the panelists think OpenRAN deployments will almost reach their heyday? And Eugina, do you want to lead off on that question?
Absolutely. I'm going to reference the LoRa report that they published, and they're seeing OpenRAN accelerating in the next 2 years. And we see many different deals that Parallel Wireless or Mavenir is announcing in the US and globally, because they're not selecting OpenRAN as the technology. They're selecting the best of breed RAN. So we're hoping to make many more announcements in the upcoming year and to show the world that OpenRAN is the way to build networks for 5G, 6G, 7G.
Got it. But Stephen, Douglas, did you have a particular view as being sort of fairly neutral?
Yeah, I mean, just looking at some of our, let's say, the service provider roadmaps, which we're privy to, and I can't certainly share who, but just from a general perspective, you're sort of seeing 2024 is seen by many as a point where I think you see the OpenRAN coming more into their networks from what they would call the dense urban deployments, and I think that's the catalyst for its real growth within at least 5G. So I'd expect sort of in 2024 on to see sort of that growth curve starting to rise, and it's still going to be sort of maybe 10-15% of the overall RAN gradually going up, but there is big ambitions. I think even Telefonica has publicly stated that they would like to see by 2025 at least 50% of their cell sites OpenRAN as at least as an aspirational target. So I think that's an interesting sort of statement.
Great. And any other panelists? I'm cautious about asking you, Joanna, again, in terms of view on OpenRAN.
Yeah, I don't make forward-leading statements in my part of the business, but I do think that the general view of what I've heard, one of those is likely to be correct.
I'll happily chip in with a few thoughts. So I agree with everyone. If the question is, when does it reach its plateau, its peak, its full potential? I think the answer is actually 6G, because most of the 5G contracts have been placed and most of the 5G build is well underway. But I think it will grow, very significantly from now onwards. So I'm not saying in any way that there's no ORAN till 6G. I think there's plenty of ORAN between now and 6G. But I think, when's it actually going to get to its full potential? I think it'll be with the 6G contracts.
Okay.
Yeah, and I would just add on the some of this will be delayed on the supply chain side of things, based on some of the quotes on delivery times of some basic equipment. Could be up to a year delayed on getting some of this stuff.
Okay. Well, that's a really helpful insight. Well, we're sort of running out of time, but thanks to all the panelists for what was a fascinating discussion, and for all the attendees on the line. You'll be able to get a recording of the webinar, and if you've got any further questions to ask the panelists, then submit these to myself, and I'll make sure that one of the panelists gets back to you. But thanks again for your time.
Cheers.